Hello, I'm Robert. Welcome to my channel, Fact Checking in Science, and to help you when you're scared of many things. And this is to help people who are scared because they see things that seem a bit unusual with them about the moon or the sun. And this particular one is, this is one of the things we often get asked, is people who get scared because they spot the moon in the daytime. That is very common. The moon is in the daytime most of the month. For half the month, for most of the month, all of the month really, except for full moon and new moon, you'll see the moon in the daytime at some point in the month, in the day, or night, in the early morning or the late evening, or in the middle of the day. And so, why are people so surprised when they see the you can see what I've been watching recently. Anyway, never mind. So why are people so surprised? And it's just because they're not very observant. They just don't, they just spend, and especially nowadays, a lot of people just spend a lot of time looking at their mobile phones, walking around, talking to each other, and they just don't look at the sky. And then someone tells them, oh, the moon is doing something funny, and they look at the sky, and they say, oh look, there's the moon. What's the moon doing in daytime? And what has happened is just they've looked at the sky for the first time in their lives, really. They've really started to pay attention to it a little bit, instead of the sky being a kind of backdrop to their life they don't really look at. And that's all that happens there. So another thing that happens, they may look and they may notice, so let's just bring this one up. Well, that's it, full size apparently. So they look at the sky and they look at the moon and they say, well, sometimes the moon is facing one way and sometimes the moon is facing the other way. 2 weeks ago the moon was facing a different direction. How can that be? And what they don't understand is that the lit up part of the moon always faces towards the sun. So you can actually use the moon as a kind of arrow almost. The sun would be that way, that way, that way. The sun is behind your head if you've got a full moon, like that, like that, and like that. It's different in the northern and southern hemisphere because in the southern hemisphere you're basically upside down compared to people in the northern hemisphere, and so that's why the moon looks kind of back to front. And you see in the northern hemisphere you're used to the sun rising on the left and setting on the right. You always used to the sun crossing the sky from left to right. And the moon too. If you're in the southern hemisphere, you're used to it the other way around. You're used to the sun rising on the right and setting on the left. And the real difference is just that you're upside down relative to the people in the northern hemisphere, or we're upside down relative to them. That's all that's happening there. And this shows how the yes, I can't find that one either. This one shows how the phase of the moon relate to the time of the day when you see it. So at the full moon, then the full moon is exactly opposite the sun. So it's at its highest in the sky at midnight. It's there from 6 p.m. to 6 a.m. This is assuming you're living near the equator when it's the mass is simplest. So 6 a.m. to 6 p.m. you'll see the full moon. And then if you're looking at the first quarter moon, then that's going to be visible from noon through to midnight. And if it's the last quarter moon, it's going to be visible from, so that's the waxing, means it's growing, this is waning, means it's shrinking. It's going from full to new. So if you see the third quarter moon, then it's going to be there from midnight through to noon. And that's why you can always see the moon in daytime except at full moon. And when it's full moon, then the moon rises when the sun sets at the opposite side of the sky, and then it sets when the sun rises. And that's full moon. And then when it's at new moon, then the moon is and it's just the moon orbiting around the earth, and as it orbits around the earth, when it's a new moon, it's on the side of earth towards the sun. and so it rises and sets with the sun, and so you can't see it from this side. When it's from that side, and the sun's, because it's lit up from behind, so the moon just looks black against a black sky. If it weren't for the blues, if you were on the moon, well, obviously you won't see the moon if you're on the moon, but if you were in orbit in the ISS or something, and you look towards the new moon, then you see a very, very, very tiny, very slender crescent, if you could block out the sun, and which you can do very easily, and then you just look out of the window from the ISS, you see a slimmest of crescents, and you maybe won't see that at all, and then it's just be a black patch in the sky against the stars. So, but from the Earth, then we can't see it. We can see it a very young crescent moon or a very old crescent moon, but we can't see the moon when it's the very thinnest crescent moons. We can't see because it's just too faint to see against the because you see it with the blue sky behind it, well, the blue sky in front of it. So the sky is, when the sky is blue, then only very bright things can be seen through it, and the new moon is it's obviously as black as seen from this side, so you just don't see anything through the blue sky. So that's basically most of the things about the moon. And I was just going to explain one more thing. I'll bring up another window, so just a minute. So this is to explain about some people. So there was one post that was given to the group, and recently, and someone saying, "Oh, the world's going to end," or something, or Jesus is going to return, or something, or I can't remember what it was now, because the sun has risen further north than it was a few weeks ago. So that's another thing. You've just never noticed the sky, never noticed the sun really, and you've never noticed that the sun rises in a different place every day. So that's where it rose on 20th of February. Now if we go back in time here, and we go back to the December and 21st, which was the winter solstice, then that's when it rose. As you can see, then it rises much further south, and it just spends a little bit of time in the sky. If you go further up north like that, if you can bring this right up, let's bring it out again. So now if you go up first, you see there you are, now north of the Arctic Circle, and so the sun is always below the horizon, and just a little bit below that, there we are. It's very quick, the motion, so you just go down a little bit below the Arctic Circle, then you see that the sun will just rise a tiny little bit and then dip again. And then you explain that bit again about if you're in the southern hemisphere, and then if at the same time, if you keep on going down and down to the southern hemisphere, then it goes the other way around, you see. So I'm just going to explain, there we go down to the southern hemisphere. And that's what happens to the southern hemisphere, remember I said that in the southern hemisphere, you see the sun up this way. So you see the sun rising to your right, and then setting to the left, instead of the other way around. And of course it's the southern hemisphere summer, so if you go right all the way down to the Arctic Circle, then you get the same thing. Now it's always daylight there. So it's the same sort of thing when you go above that point. There we are. And then you start getting the sun just setting for a little while. So you can play around, if you play around with this map for a while, then you can get, it's a very good way of getting a good idea of how the sun works, which most people don't know. Just don't have a clue. And that, I think, is the twilight, that bit there, I think. I'm not sure, I have to double check that. Anyway, and so you can try going through the go to, so if you go to the northern hemisphere to June, say, let's pick a date in June, it's like that, maybe just like the northern hemisphere, the southern hemisphere was. The sun then rises very far north, and I'm up in Scotland, so we see quite a big difference between Scotland and England, especially when you get close to the solstices. So I mean, if I go back, when's the summer solstice now? Let me just stop a minute. I'll find the date of the summer solstice. 21st of June. Let me just find that. That's the summer solstice. And so it's not. It doesn't seem such a big difference, but it is really. So I mean, you're looking at the difference between that and. So if I bring that down, if you go to England, then if you go up to where I live in Scotland, you have a noticeably longer day in the summer. And then if you go to the same date in December, which is the winter solstice, we have days that only what have I gone down? December 21 again. Right. So in Scotland we have days that are less than 8 hours of sunlight in the middle of winter. And it's significantly more just a little bit further south in London. I used to live near Oxford, and now I live right up here, up in the north, near the north of Scotland, and I have noticeably shorter days in the winter and noticeably longer days in the summer. Anyway, so that's just like the basics of that, and then I'm just going to bring up one more window. Yes, I'll do that. Now, this is where it gets really complicated, and I'd actually got some of this wrong when I wrote this article. It was a year or two ago, and the amateur astronomers in the Doomsday Debunk group put me right on a few mistakes that I had about this. It's about how the moon works, and especially I got a bit confused about that. But anyway, this is about again where it rises and sets. I'm just explaining a little bit better why I just talked about where it rising and setting in different places. So first of all, it's because the Earth's axis is tilted that you get all this, and that's the Arctic Circle I was talking about. And so the Earth's axis is tilted like that. When it orbits around the Sun, it keeps tilted the same way. When it's the other side of the Sun, then that pole is tilted towards the Sun. But the Earth isn't pointing in a different direction. It's always pointing in the same direction. But as it orbits the Sun comes from a different part of it relative to the tilt. So that's what it looks like. The summer solstice is when it's the other way around. So the Earth hasn't changed its tilt. It's rather we're looking at that kind of flipped, because it's the other side of the Sun. Now, this explains how this whole thing works about the summer and winter. So lots of people get confused about this, and they think that the Sun rises at a different angle in the summer. They think it rises more steeply in the summer than in the winter. But it rises at the same angle every time of year. The angle that it makes to the horizon as it rises, and yet the solid angle, the angle of the plane to the plane of your horizon, it's always the same. It depends on your latitude, and it's due to this tilt. But in summer, then so that's the December solstice. So where I am, it's less than 8 hours. Then it rises. It spends just a little bit of time, and then it goes down again because it rises very far south. So it's relative to where you are. That's very far south. So it rises there and just does like that. And then in summer, where I live, it rises very far. Of course, where I am, it's the other way around, left, going like that, back like that. So it rises like that. And then in the equinoxes, then the two of those each year, then in the spring and in the autumn, then it rises exactly east and sets exactly west. And that's the only time of year that it does that. And then in summer, it rises very far north and then sets, but it's exactly the same angle in the sky. but it's a very steep angle relative to you. It's going a different angle relative to the horizon, the same angle relative to the horizon. So most people don't realise that. And then the moon gets very complicated. I don't know if it's quite difficult to know where to start explaining that. But the but the thing is that at the new moon, so basically the moon is doing all this stuff. So at the new moon, the moon rises and sets with the sun. So if that was in winter here, then at new moon the moon would rise very just a short time and go down. And then when it is full moon, it rises and sets opposite the sun. So it does this graph like that. So when the sun does that, when it's there at full moon, the moon then rises then. And so the sun might spend at full moon, then the sun will spend where I live less than 8 hours during the winter solstice. And then at the end of that, the sun rises. It's always directly opposite the sun at full moon, almost directly. So it rises when the sun sets, and so it'll spend 16 hours at night where I live at full moon, and it'll be very high at full moon. And then at new moon, again winter solstice, it rises and sets with the sun. So the crescent moon is really quite hard to spot if you're in a northerly altitude, and if you've got, as I've got, we've got quite high hills to the south of where I live. So the new moon in winter will get hidden behind the hills, but the full moon is very easy to watch, and I actually see it outside my window from my house, because it sets really high up. Indeed, you could see it rises and sets really quite far north. And then in summer it's the other way around. So in the summer it's really quite hard to spot the full moon from where I live, because it only spends 8 hours up, of course, because we've got the very short nights and it's very near the horizon. But in summer it's very easy to spot the crescent moon, because that rises and sets very close to the sun, so it's in the sky most of the day. So that, again, most people don't know that. That's something I got confused about. I'm not much of an observational astronomer, and I moved up here, and I just really hadn't really noticed how it all worked. And but it was obvious once they put it out. Once they pointed it out to me, it was kind of obvious. But it took me quite a while to get this all sorted out. And that's because that's all I wanted to explain. And then again, the sun and the moon, they rise faster at the equinoxes. So people sometimes say, "Oh, I've noticed the sun and moon, they're rising faster, or they're rising a bit slower." And that again, that depends. You can work out that at the equinoxes they rise and set at their fastest, and then at the other times of year they're a bit slower. You won't notice this very much if you're in equatorial regions, I don't think. But if you're at high altitude like I am, and that's because the sun you can see that most easily, for instance, if you if you were, for instance, if you were all the way up at the Arctic Circle, then the sun would just skim above the horizon and then go down again in the and at the equinoxes. No, at the winter solstice. No, sorry, in the middle of the winter. And you're just on the Arctic Circle in the middle of winter, the sun will just dip above the horizon, and at that point it's going almost horizontally, so it will spend an awful lot of time doing that. And then it's the same the other way around. In the middle of the summer at the equinoxes, it'll just dip right down to the horizon, and would dip just down below it, and be going almost horizontally when it's near the horizon. So the sun rises and sets very slowly if you're close to the Arctic Circle at the solstices, at the winter and summer solstices, but in the equinoxes it rises at its fastest and sets at its fastest. And that's the same everywhere, but it's most noticeable if you're very close to the Arctic Circle. And I think I'll try and figure this one more thing I wanted to say. If you're at the North Pole, then so once you're further up beyond the Arctic Circle, if you're right up here up at the North Pole, then right at the North Pole, then you see the sun doing a kind of spiral around you. And let me just pause a minute. I'll just think for a minute now. I'll complete this properly. Yeah. So if you were living exactly in this Earth, there are people who live at the pole in Antarctica. Well, there's an Antarctica station, South Pole Station now. So I think there would be people who live there, and what they see is that because the pole, because they're just pointing in a particular direction in space all the time, and the Earth is spinning around beneath them, then when it's in the summer, they just see the sun at a particular height in the sky, and it goes round and round at that same height all the time. And then as it approaches winter at the equinoxes, then if you're at the South Pole, you will see the sun just skimming around the horizon, and then half the sun above and half below the horizon, if you can imagine a perfectly flat horizon, if you can manage to find that. And you'll just see this half the sun skimming around the horizon with half of it showing above it. And then it'll get lower and lower, and then it's below the horizon, and then from then on it's night. So basically you just have one day and one night if you're at the South Pole. You see the sun slowly spiral up and up into the sky until it reaches its highest, then it spirals down and down and down, then it skims around the horizon, and so your sunrise and sunset, your sunrise basically takes ages, because it's just skimming around the horizon, round and round in the spiral down, until eventually it's got below the horizon, and then it's night, and then it stays night all the way through for 6 months, and then back the sun comes and it starts spiraling up again. And then if you are at the North Pole, it's just the same but the opposite way around. So you have you have it in our winter like it is now. Then if you were at the North Pole, and you'd have to be an icebreaker there because there's no land at the North Pole, then or in a temporary camp or something like that, then you won't see the sun for 6 months of the year. Then you see it skim around the horizon, then it starts rising at the very moment that it's got missing, that it's disappeared out of the South Pole sky. So I think that's basically all that. You've got all the basics of how the sun, moon and the earth work, and hopefully that'll help you all to understand a little bit easier what's going on when you see these things. It can seem quite strange if you've never looked at the sun before, and even if you have looked at the sun before, then you might have seen all these things, but some of you may not have quite understood how it worked, and particularly the way the moon works. That's really quite complicated. The basic thing with the moon is to remember that the moon rises opposite the sun and sets opposite the sun at full moon, and it rises and sets with the sun at new moon. And so it basically goes through all the things that the sun does, but it does them in winter, but it does them in a single month instead of over the entire year. Anyway, so that's that. I'll upload this, and just a shout out for our Doomsday Debunk group on Facebook, and where a lot of people there who are really pretty good at astronomy there, keen amateurs and a keen amateur astronomer gets to be really quite expert at astronomy. They have to for what they do, and they can answer all sorts of technical questions. Things like this are very easy for them, and so Look, we have a few in the group like that who just answer this, and they're out with their telescopes every day, every night, and sometimes with solar scopes in the daytime. So they always know where the sun is in the sky and what the phase of the moon is and where the moon is, and all these things. Far more aware, at least far more aware than most of us are of such things. If you do join the group, do be sure to have a look at the rules at the head of the group. And we welcome both debunkers to help scare people and people who are scared and just come there to ask questions about all these things.